Hello, this is the setup that is in the recorded lecture. So let's just demonstrate it once and then we'll discuss what it is. Here's a marble, and here's a ramp, and then here's a paper catcher. Okay, and let's first off see how it goes. Just do a trial run. There's not going to take any data here. We let the marble go down, and there you go, and it skidded this far. So we can put this little red marker here where it stopped. So it started here, went to there. So this is the experiment we will be doing, okay? And then what we'll do, then we'll measure with a second ruler. This is the metal ruler in your kit. We're going to measure the distance, the skid distance here, how long it took to skid to a stop. Now what we have here, first off, this piece of wood, this is ash actually, which is a nice smooth hardwood, and it's cut like this. So we can raise this ramp, we can raise this end of the ramp by 3 amounts. We can raise it by this amount, we can turn the block this way and raise it by this amount, and we can put the block this way and raise it by this amount. So we can raise, we have 3 different heights that we can raise the ramp to. So let's first off put this way, and I will measure these 3 distances with the ruler we have here in centimeters. Okay, so first off we put this here. So we have a rather gentle ramp here, and then the ramp itself, which is, I just took the ruler we have, metal ruler, and made a trough, okay, just out of paper, and I taped it on both ends. So the marble now has a nice smooth run down, and there's basically no friction there. And then this, then I put this little wedge, the skidder I'll call it here. I'll put it here so it'll catch with its apex right at the little line here, which is my measurement, and then we let this go down. So let's go, we'll do that one more time, and you'll see it goes that way. So now it actually, you see it went a little farther than the previous time. I don't have an easy explanation for that, but that's what it did. Okay? Now, so let's just take a mental note here. This went about 12 centimeters, okay? 12 centimeters of skid. So let's, for fun, crank up the height, okay? So make the height bigger here, and then we'll do the same again, and we'll see how far the skid distance is. Okay, skid distance now looks like it's about 23 centimeters, okay? So we started out at a higher height, so the gravitational potential energy was more, at the bottom kinetic energy was more, and it skidded a longer distance. So that, and now just one more, just to show you the third one, we're going to raise it up really high, the height of this. So we're going to have to back off here because we're going to need more skid room, and I'll do the measurements later. And so here we go. We put this like this, and now I think I have enough room out to here. I just put tape. I put paper down, so we'll have a nice smooth surface because this wooden table is not that smooth. Okay, so here we go. Went that far. Okay. So this is about 30 centimeters. This is about 60 centimeters, and to here, 68 centimeters total, okay? It went 68 centimeters. And so that's the total skid distance, you can see. So now this, so now we're kind of ready to do some measurements, right? So I'm going to, as a good experimenter, I'm going to keep some notes, and let me keep from your laboratory notebook, which you should be using to keep notes. I'm going to measure the mass of the marble with our electronic balance that we used on the first week. With a ruler, I'm going to measure the height of this, okay? And then G is the acceleration of gravity, that's 10 meters per second squared, okay? So we know mgh, and that's the gravitational potential energy we started with. As it rolls down, now when h is now 0 just at the table height, it will have a kinetic energy which should equal mgh, and then it'll skid through a skid distance, so there'll be a friction force here, a constant friction force, and it'll skid a certain distance s, we'll call it the skid distance s, and so the friction force times the distance is the work that is done by the rolling marble, and that friction force should actually equal the kinetic energy at this point and equal the gravitational potential energy we started out with in the beginning. So I'm going to do several trials. I'll just say 5 or 6 trials, maybe 10. And then I'll average them to get an estimate. You saw that we made 2 measurements and both of them differed by a couple of centimeters. I don't know why. I'll try to keep the conditions the same so we have reproducible results and get a, say, for example, a good average. So that's the experiment for this whole week. Okay? Now, so I will go make a bunch of measurements and then present the results to you in the recorded lecture. And then this is something you can do. You need 3 pieces of computer paper, scissors and the tape, and maybe an extra ruler. But you know, in week 1, you know, we developed ways to measure distances with our hands, so you don't even need a ruler if you want to do here this and this, okay, and so on. Okay, so there you go. So I'll do several runs, get an average. I'll record the results and show them to you later on. Okay.